Thank you very much. I'm very happy to be with you and share some of the interesting work we are doing in modeling complex systems. The topic today will be brief introduction of something that's named Global Change Explorer, the publicly available web-based tool for exploring the impacts of global change. I think for this audience, kind of introducing global change is not something very new, but when we talk about global change, I keep in mind the change that's occurring within the kind of population, both growth and migrations of the population, change that's occurring in the kind of land use area, especially switch from agriculture to urbanized land or switch from the forest to agricultural land. And finally, very big issue of changing climate. The reason for the focus on the global change is that the impacts are spread all around the kind of infrastructure, both hard and soft. Our water infrastructure, energy, transportation, communications, everything is kind of affected by these globally changing conditions. But we quite often forget that soft infrastructure like institutions, social organizations, even the culture is also being subject to these globally changing conditions. And the final outcome is that if we are trying to assess the impacts of global change, we are facing the very significant increase in the complexity of the problems we are trying to solve, as well as the uncertainty involved in their formulation and solution. I'll give you just a bit of history of this work. I assume that no one at this call is old enough to remember the 1970s and publication of the seminal work of the group from MIT and the development of the world model that was looking into limitations to growth. That work ended up with a book, The Limits to Growth. You see the book on the right-hand side. The book, I think, reached approximately 32 million copies. It was translated in about 30, 40 languages. And it was probably one of the scientific books that reached the maximum popularity. I was a graduate student at the University of California at that time, and I got an assignment in the course to read the book and write the essay. I did it. I got a pretty good mark, but I was left with a very, very large question. And the question was, how come that when we are considering the limits of the growth, we are not considering water? The world model didn't have anything to do with water. And I think that stuck in my mind as one of the really important questions to address. So yes, I came back to this particular question. First, I took the model of the limits to growth, the world model. I added the water to it, and I resimulated all the scenarios that the book was based on. And I think I successfully proved that water can modify them all. Much later on, I also continued the development of our own model that was built kind of having in mind the concept of the world model, but focusing the interaction between sectors in a very different way, putting the water quantity, quality, supply, demand, and everything else in the center, and then linking it to other sectors. That work on the development of that model, that's right now in the version 3, also ended up in this publicly available tool that I am going to kind of show today. Just to quickly show you, this was the beginning, the modification of the world model. World model had all these sectors from industrial, food production, pollution, and so on. And all what I have done, I kind of added this water quantity and non-renewable and renewable. And then on the right-hand side, you see the simulations. These are the traditional simulations of the scenarios published in the book and the follow-up book, Beyond the Limits. 12 different scenarios, and almost each of them were dramatically affected by the water, pointing out that especially water quality is one of the really significant issues on the global scale. And then much later, the development of the ANEMI model, our original model, started. It was supported by the Natural Sciences and Engineering Research Council of Canada through a number of different grants. I really appreciate the strategic grant that gave us opportunity to work in an interdisciplinary team with a group of very significant partners that helped shape the model and basically support the idea of developing a system-based model of society biosphere climate system that would help communication between the science and policy. So the members of the team, all from different groups, you can see economics, policy, political sciences, systems modeling, engineering, worked with the representatives of the federal departments of environment, natural resources, finance, fisheries, and agriculture in order to kind of develop and transfer the model to these departments for their policy making. This is the kind of high-level structure representation. The model currently has 12 different sectors, from climate, carbon, population, land use, to nutrient cycles, water supply, persistent pollution. And in different colors, if you can see on this slide, are the kind of intersectoral feedbacks. Each of the sectors is a very detailed now model in itself. It includes approximately 600-700 differential equations and state variables and uncounted number of feedback relationships. We came up to some estimate of over 8,000 feedbacks acting together in order to produce the kind of dynamic behavior of such a complex system. But the point was that we successfully kind of connected. Let's follow the red line, like the carbon sector, climate, food production, population, and then energy and economy that affects, again, the carbon. And you can follow the other colors and see how these different sectors interact between themselves, and by this interaction actually create that complex behavior. The model was validated, running it in the past and comparing to some available data. And you can see the dashed lines are the model performance, showing different variables here, and the full lines are observations. And the kind of verification period or validation period was between 1980 and 2020. And then we used the model to kind of run the future set of future scenarios. On this couple of slides, I'm showing also the comparison with different research outcomes that are also dealing with these longer term predictions. The key point in understanding this type of modeling is that the purpose of this type of model is not to tell us what, in 2053 what will be the concentration of the atmospheric CO2. No, it's actually to tell us what is the kind of trend that the atmospheric CO2 will be taking over the longer period of time as a consequence of the particular policy options, adaptation options, the behavioral options, so the population, industrial choices, and so on. So on the basis of this model, we developed a kind of user-friendly interface and provided this on the web for general public use. I'll try to see if I can successfully demonstrate the model. This is the address that the model can be kind of accessed. Okay, I think this should bring me into the model. Yes, this is the interface of the Global kind of Change Explorer. There are very simple set of steps that the user can take to kind of simulate and run the model in real time on the web. The model or the Explorer has a number of scenarios that are already preloaded, dealing with the climate change, population, water security. And then within each of these scenarios, number of uh, questions that by experimentation the user can answer. So let's say if I am interested into climate change, I can pose the question, what will be the impact of climate change or energy production, and select this particular kind of scenario that will give me now the working environment. On the left-hand side, there is a so-called the summary graph that shows together a set of variables that are selected by ourselves to address the question that's being investigated. But in addition to this kind of set of combined information, we provide a very detailed information for almost all significant variables to that particular investigation. So these graphs are individual graphs showing, population, precipitation, energy production, carbon emissions, and so on. So the way how the model works is on the right-hand side, you have a description of the kind of scenario that you are running. In the middle box, you have a description and definition of all the variables. Number of variables are preset with each of the scenario. These are the variables which are required as initial conditions for running the simulations. And the number of variables that the user can experiment with are provided on the right-hand side. So by using these sliders and modifying the values, the user can easily run the simulation. The model is now running in the real time, and it will now show the results of the simulation, which was consequence of selecting these input variables. I didn't select something drastic, but you will see there are actually two graphs now, the based conditions as well as the selected. Let's select something more drastic, like a very conservative climate change emissions scenario, RCP 8.5, rerun the simulation, and you will see model is again now simulating, and it will be presenting the results of this particular graph. Now we are observing much more significant differences. These differences are pointing out and being kind of saved in the background. Just to finish, the model stores the information for all the runs and simulations. They can be exported in the form of the Excel tables. They can be shared between different users. And also the the interface provides some kind of help through the access to user manual and the number of publications that are already available. So let me finish just to point out the direction we are going on from this kind of global modeling perspective. I am now very much interested in coming down to regional scales. About 10 days ago, we completed the model with a very similar structure, but focusing only on the Yangtze River Basin in China. The publications are in process, and I think very different type of interactions which are occurring on the regional scale are being kind of assessed. Theoretically, we are interested in the interaction between the processes occurring on different scales, like global processes like climate change and regional processes, let's say economic decisions, investment decisions, or particular decisions related to population or urbanization and so on. And the third kind of direction we are going on is expanding the Global Change Explorer by increasing basically the number of scenarios that are going to be available to the users. We are very much open for the feedback, looking forward to learn from the users what the interests are, what the opinions are about the current system, and obviously trying to tailor and build the tool to the level to be of interest to more people. With this, I'll be happy to answer some questions when we come to that part of the day. James, back to you.